by showing the circuit diagram. So whenever in a circuit diagram we are connecting ammeter, obviously the polarities you have to always keep in mind. It is always connected in series. Ammeter is always connected in series. Always connected in series. Whereas voltmeter is always connected parallel. Now the condition is ammeter has low resistance. Keep this in mind, we'll discuss. And voltmeter has very high resistance. So voltmeter is having very high resistance. So it has to be always connected in parallel to the appliance or wherever you want to know the potential difference. Now we will discuss why this is so. See, try to understand practically. You have to remember this concept also. Let us believe that अगर हमने ammeter को parallel में लगाया तो what will happen? The current flows here and it will divide. Since it is very low resistance, so the maximum current will flow in the ammeter. The current in the other side will go very less. The maximum will go into the ammeter and ammeter will burn. It will burn because we will understand why it will burn in the next topic, why it will heat up. But that is for sure, ammeter should not be connected in parallel. Now this is very high resistance. If voltmeter is connected in series, the amount of current in the circuit will drop very high because high resistance will add to the resistance of the circuit. Because you know that in series, if you put something in series, the overall resistance increases. So the total current in the circuit will also decrease because resistance increases in the circuit. So obviously voltmeter will not get damaged, but the other appliances will not be able to work to their potential. So make a note. This is very important that ammeter is always connected in series, whereas voltmeter is always connected in parallel because of the two reasons, right? Next, the concept which I'm going to discuss today will also answer why ammeter will get burned. See, in 9th standard, we studied about work energy. So work energy means wherever there is work, some energy is consumed, or if some energy is consumed, some work has been done. So this is what we studied in mechanics. It is also applicable in electronics and electrical also. So what kind of work is done here? Lavish?
Yes, sir.
What kind of work is done in electric circuit?
To move coulomb of charge.
Right. To move the charge particle. So the definition also tells us the potential difference across the conductor is work done in moving a charge. So from our 9th class information, we can say that work done is equal to energy consumed. And we have seen in all the cases, maybe mechanical or any kind of work, even when we work, a body gets heat up. Why? Because there's a transformation of energy. Maybe some mechanical work is done, like fan is rotating. the mechanical thing is turning, the appliance gets heat up. You see any electronic gadget also, like your mobiles also, they keep on working, they get heat up. You might have experienced that when you're working with mobiles, they get heat up. Why? Because some work has been done. Maybe it's in the form of showing some display, that is light, or it is showing some music, it's just playing a music, or you're just visualizing something over there. Some work is done. In that case, the electrons are being moved. So some work is done, some energy is consumed, and the heat is involved. So when you have understood from your ninth standard, here we bring the concept from this information, that is Joules heating effect, which is actually, by definition, you can say it is the amount of work done in moving the charge in an electric field. So when you look at this expression, W, that is work done, is equals to potential difference into charge that has been moved in that field. We cannot measure Q, because to measure Q, we don't have any specific instrument. So the best instruments available in electric circuit is the ammeter and voltmeter. That means we have either potential difference that is there in the expression, so we will measure from here. And when you look into Q, we also know that I is equal to Q upon T, and Q can be replaced as I into T, current into time, where Q is the charge, T is the time for which it flows, and I is the current that has flown in the circuit. So from 1 and 2, the amount of work becomes V into I into T, and so is the energy produced in the form of heat. The heat in the appliance is according to the amount of potential difference it has been put across, the amount of current flowing through it, and how long you've been using it. The longer you use, more heat is produced. So we have one relation, which is V into I into T. This relation is not exactly explaining the Joules heating effect, because in the heating appliances, when you use heating appliances, we prefer to use what was that? So Joules heating effect, when we are looking into the heating appliances, we look for a appliance which has high resistance. So we look for the resistance in the expression. So can we express this in current, resistance of the appliance, and time? We'll use the Ohm's law. According to Ohm's law, V is equals to IR. Ohm's law relation gives us V is equals to IR. So we can put this in equation 3. Put value of 4 in 3, we get H is equals to I square R into T. So this expression is best used for, although that expression is also giving us energy. It is also talking about energy. But the best explanation is provided by H is equals to I square R into T, because when you look upon heating appliances, the very foremost thing we look upon is the resistance of the circuit. We always prefer high resistive elements in the heating appliances like geysers, microwaves, ovens, all these kind of things. We prefer to have this, because current we can regulate, we have to alter the potential, but generally we are looking into 220 volt in our domestic circuits, so we cannot change V. So the best thing which we can have is the resistance, and for longer time, little longer time, we will use that to heat up. Like ovens also, they reach to high heat temperature, you can say, when you have to when you switch it on for longer time. So this is the expression which Joules heating effect provides us, and let us know how the heating effect is there. So we'll get back to this, where we said if you put ammeter in a circuit, high current will go in, and the high current means it will raise to square times. So if large amount of current flows through this, if ammeter is connected in parallel, so it will burn and ammeter will get spoiled. So this is regarding the Joules heating effect. So electric power, before I just get into this, what is the unit of heat produced? Anyone? Joules. Power is defined as work done per unit time, or we can say that heat produced per unit time. So the relation we had, V into I into T upon T. So the first relation is P is equals to VI. This is the first relation. Even P is equals to I square R into T upon T. So the second relation is P is equals to I square R. One more relation, we can add this relation over here. If you replace I by V by R, Ohm's law say V by R. So the relation is V square by R into T. तो एक ये relation भी है, और ये relation कब use करना है, that I am going to discuss in this topic. So P is equals to V square by R into T upon T. That means P is equals to V square by R. So these are the three relations where you can calculate power. So whenever you are talking about heating appliances and power, then you will look this. This relation is helpful. When you are doing in the electric circuits, then you look for this. And when you are talking about parallel circuits, parallel, look for this circuit. So something very interesting is coming up, how power and resistance are related. How power of appliance is related to resistance of it. It means appliance. This expression tells that power is inversely proportional to R when V is constant, and you know that potential difference is constant in parallel circuits. So जो resistance के साथ आप करते हैं उसका inverse you will do for the power of the circuit. अगर दो तीन appliances की power calculate करना है तो आपने inversely relate करना है. जैसे कि series आ जाए तो series में total power is calculated as the reciprocal of the powers, और parallel में टोटल पावर कितनी हो जाएगी? P1 plus P2 plus P3, reverse of what you did for the resistance, total resistance of the circuit.